Napier being all genius and brilliant and everything, the crazy Scotsman who invented this, you don't have a way to solve for an exponent when it's in the exponential part. Okay, you don't at this point. You were never given a reverse to exponents in the order of operations until logarithms. We could use logarithms to solve this. There's two ways to do it. But I'm going to show you first. Actually, I'm going to do logarithms first. If I'm going to use logarithms to solve this without a calculator, okay, what base would I use? Look at the 4 and the 8. Look at the bases of the exponents and tell me what base of a logarithm do you think would help us solve this? 2. Because 4 is 2 squared, 8 is 2 cubed. So if your bases are both powers of the same thing, you can solve this by taking the log base 2 of both sides. Okay? Now, what do logarithms, you have to do it to both sides. It's like anything else when you're solving an equation. You can't do it to just one. Now, what do logarithms let you do with exponents? It lets you cancel them if the bases are the same, but this is not log base 3x.
Reverse them.
Reverse them. What's the word I used? Anybody remember? Pardon? Schloop is close. I said whoosh. Bless you, Elise. I said whoosh. It lets you take an exponent and turn it into a coefficient. Now, we picked 2 because 4 and 8 are both powers of 2. Every logarithm is a question, and the answer is an exponent. 2 raised to the what power is 4? To the 2, not a stumper. So log base 2 of 4 is 2. So this becomes 3x times 2. 2 raised to what power is 8? 3. 2 to the 4th gives me 16. So 2 cubed gives me 8. So this is x plus 1, leave that in parentheses, times 3. Just look like something you can solve? Don't let me think you need to go back to algebra 1. What's 3x times 2?
6x.
Yes, very good. I distribute the 3, and I get what?
3x plus
3x plus 1 times 3?
3. God, you're stupid.
Stop. Don't go there.
Okay.
I know. All right. But you're kidding for posterity. Okay, now I subtract 3x from both sides. You guys good with that? I get 3x equals 3. So x equals 1 is the solution to this equation. Okay. Now the key here. Pardon? Which one? Oh, so 4 cubed does equal 8 squared. They're both 64. If you plug it back in and check. Yes, it does work. There's another way to do this that actually doesn't involve logarithms. But it requires you to notice the same thing. You can go straight from here and notice that 4 is 2 squared. So I'm rewriting 4 to the 3x as 2 squared to the 3x. Then you can go here and you can notice that 8 is 2 cubed. That's raised to the x plus 1.
What are you doing?
I'm rewriting the 4 as 2 squared. And I'm rewriting the 8 as 2 cubed. Now when you're raising a power to another power, what do? Multiply. So this becomes 2 to the 3x equals 2 to the, I'm sorry, it does not become 2 to the 3x. What mistake did I just make? 2 to the 6x. Thank you, Saul.
Silly rabbit.
Exactly. This becomes 3 to the x plus 1. And that's 3x plus 3. Now this is, there's a couple of ways you can think of this. Yeah. Here's how I like to think of this one. If 2 raised to the 6x equals the same thing as 2 raised to the 3x plus 3, what do you think is true about these two expressions?
They're the same.
They're the same. If 2 raised to something equals 2 raised to something else, they can only be equal if these two things are the same. set them equal, solve. Well, now, here, how did I do which? Just this step? I just observed. Here's how I like to think about this. It's not the only way to. I just made the observation that if you raise 2 to this expression, and it's equal to when you raise 2 to this expression, these expressions would have to be equal for this statement to be true. It's like everything else is the same.
Where'd you get the 6x?
I'm just taking these 2 parts of the expression, the only 2 that are different, and setting up a new equation. Since based on this expression, they have to be equal.
Is it a random equation?
Not random at all. I took the 6x from here and the 3x plus 3 from this exponent. These exponents have to be equal if the bases are the same. That's if the bases are the same. That's why I can't do it from the first step over there. I can't look at this. I cannot look at this and I can't just say, oh, this exponent's equal to this exponent because the bases are different. But if I can make the bases the same, then I can set them equal.
Is that done?
That one's done those 2 ways. I'm going to do a couple more examples of some slightly uglier ones. But just out of curiosity, who has a preference between these 2? Saul likes that way. What do you like,
I
Layla?
like the second one.
The second one?
I think we need to practice the second one.
The second one needs more? Let me get to a few that absolutely need logarithms. Okay?
I like the second one because I don't like logarithms.
You don't like logarithms. All right, well, let's get to one where we know that logarithms are needed. Let me force you to face your fears here.
I'm not scared of them. I don't like them.
Right, fair enough.
My eyes are so itchy.
I'm sorry.
My car is like, it was washed and shiny, and I came out this morning, it's yellow.
Yellow? Yeah, mine was yellow yesterday just from barking here. Okay, here's one where you would need your calculator. This would only be on a calculator page. 2 to the x